Okay, so let me run through this one quantitative force diagram. Remember, what you're going to do is you're going to start with a qualitative force diagram drawing, so all possible forces that are acting on the object, and then you're going to do the math. So the first part is draw that force diagram. The second part is calculate the tension in each of the identical three cables. But since they're identical, you really only need to do one calculation, and it applies to all three cables. So you've got this really heavy sculpture. Most of you have probably seen it at the Children's Museum, and it's held up by three cables going off at 24 degrees. It can't go straight up because there's a glass ceiling. There's nothing to hook it to, so it goes into the concrete straight out. So let's do these diagrams here. We have always the force of gravity, okay? And that's always going to there's no surface to tilt, so we're going to draw the force of gravity. There's no surface, so there's no normal. There's certainly tension. We have wires going out at 24 degrees, 3 of them it says. Okay. And there would be one in the back there, but we just won't do the math for that one. But it would be equal to the others, and this is 24 degrees. All right. And we have a little bit of information, but first of all, what I'm looking for is the force of tension in one of these 3 wires, and then it'll just apply to the others. Okay, and first of all, we're told that this is an 8,640 kilogram glass sculpture. Okay, well, the force of gravity, the weight, is that mass times gravity, so it's 8,640 kilograms times 9.8. So your calculator, you go 8640 times 9.8, and you get, wow, that's a lot of force there, 84,672 newtons. That's the total mass, or the total force of this entire sculpture. But each wire only holds up a third of it, so I'm going to divide by 3. And each wire is holding up 224 newtons of force. Okay, so, and remember, that's what's opposing gravity. So I have the force of gravity here is 84,672. That's all the down, and the up part of all 3 of these forces is holding, so there are 3 of them. This one back here, this one to the right, and the one to the left and one to the right. Each one of these wires has a Y and an X component. Each one of them, the Y component, is holding up 28,224. So the force of tension in the Y is 28,224 newtons for each one of the 3 wires, okay? Because this must be equal to the total of all 3 vertical components of all 3 cables. I have my triangle here. I have 24 degrees. I have one side of the triangle, 28,224 newtons. I'm going to leave my triangle right here, but I'm going to take this vertical side here. I'm going to slide it over here. I'm just going to draw it to make the math easier on myself. I'm going to go ahead and draw it. So this is 28,224 newtons. I have the angle. I have the side opposite that. And what I'm being asked to find is the hypotenuse. So I have theta, opposite, looking for hypotenuse. That means I'm going to be doing sine. So sine of theta is opposite over hypotenuse. So the sine of 24 degrees is the opposite, 28,224 newtons, divided by the hypotenuse, the force, and the tension in the wire. That's what I'm looking for. So I'm going to rearrange. I'm going to multiply force of the tension out of both sides, and I'm going to divide the sine of 24 degrees out of both sides. So the force of tension is 28,224 over sine of 24. So 28,224 divided by the sine of 24 degrees is 69,391 newtons in one wire. So calculate the tension in each of the identical three. So each one of them is 69,391 newtons per cable.